Your morning coffee is a battlefield of patents, pumps, and pressure. From the first percolators to proprietary pods, here's how design and law brewed what's in your mug. If you've ever watched your coffee drip, bubble, hiss, or politely pop out of a pod, you've witnessed over a century of engineering ideas going head-to-head. Coffee makers are tiny thermodynamics labs wrapped in plastic and chrome, powered not just by heated water and ground beans, but by the invisible currents of intellectual property. We're going to trace how three big waves, early brewers, the espresso revolution, and the home and pod era, shaped what you taste and how you make it. Along the way, we'll peek at the exact claims that made or broke fortunes, talk about a school notebook that changed coffee forever, a solar eclipse that named a legend, and a little green light that tried to lock down your kitchen. And at the end, I want your take, because your kitchen counter is the final vote in this design election. Quick question before we brew the history. What's your go-to coffee maker right now? And if you could patent one little improvement for it, just one, what would it be? Seriously, a quieter pump? A smarter shower head? A reusable pod that never sputters? Think about it and save that answer for the end. Let's start with the pre-espresso world, where gravity is king, pressure is optional, and paper accidentally becomes a superstar. First up, the percolator. For decades, this was the American default. It's simple and kind of brilliant. Water heats in the pot, rises through a tube, rains over the grounds, and cycles until the whole thing tastes like coffee. Or occasionally, like a shoe. The problem is that it keeps extracting the same grounds over and over, which can go bitter fast. Early percolator patents focused on improving the tube, the basket, and the flow paths, trying to balance extraction without boiling the life out of the cup. But the first great insurgent was the siphon, also called the vacuum pot. Light a flame under the lower globe. Water expands and climbs to the upper chamber, mingles with grounds. Then, when you remove the heat, pressure drops and the coffee gets sucked back down through a filter. It's theatrical, it's science fair chic, and it actually makes clean, delicate coffee. The key claims around these designs typically centered on the sealing method and filter interface, the bit that prevents grounds from falling through while providing a smooth return flow. Then, 1908, Melitta Bentz changes everything with a piece of notebook paper. Her story is a legend. Frustrated with gritty coffee and messy cloth filters, she borrowed a sheet of blotting paper from her son's school notebook, poked holes in a brass cup, and discovered drip nirvana. Her paper filter patent didn't just improve flavor, it changed the economics of coffee by creating a consumable that pairs with a reusable funnel. In plain terms, think of a claim that reads something like this: a filter system consisting of a receptacle or funnel with an aperture at the base, used in combination with a disposable porous paper element that retains grounds while allowing brewed liquid to pass, enabling a cleaner extraction and easy disposal. The genius is in making the paper the star. The metal funnel is durable, the paper gets tossed. That pairing, holder plus consumable, becomes a recurring business model throughout coffee history. On the ground, literally, Melitta's paper did two crucial things. It prevented fines from slipping through, and it standardized flow resistance. That meant sweeter cups and more predictable brewing. The world didn't call it laminar flow, but every morning pour does its best impression of it. Paper filters reshaped drip coffee's landscape. Home brewers could get something close to cafe clarity with a simple kettle and a cone. And that set drip up for its big moment later. But before we get there, pressure's about to crash the party. Espresso didn't start with crema. Oli machines in Italy used steam pressure, barely above atmospheric, to push water through grounds. They were fast and bold, sure, but they ran hot and tasted harsh. Then, post-war Italy gave the world a lever and a legend. Achille Gaggia's design, filed in the late 1930s and refined after the war, replaced steam with a manually operated piston. In plain Claim 1 terms, you'd see something like a coffee-making apparatus comprising a cylinder and piston actuated by a lever, configured to force heated water at high pressure through a compacted bed of ground coffee, thereby producing a concentrated beverage. That's the leap. Controlled high pressure, not boiling steam. Here's the clever trick. You pull the lever down to compress a spring, release it, and the spring drives the piston, pushing hot water through the puck at roughly 8 to 10 bars. Suddenly, oils emulsify and a fine golden foam appears, the crema. Gaggia literally marketed it as cafe crema, cream coffee, because people didn't have a word for it yet. Cafes were hooked. The lever also introduced consistency compared to pure steam. Less scorching, more flavor. Anecdotally, baristas also got a workout. These machines are gym equipment with a portafilter. The workflow was ritualistic. Grind. Dose, tamp, pull. Feel the resistance. Read the shot by sound and sight. It was artistry mugging technology in broad daylight. But the lever had limits. Your arm is not a metered pump. Spring fatigue, human variance, and temperature quirks made shot-to-shot consistency tricky. Enter 1961, and the machine that still haunts cafe menus, the Faema E61. The E61's patent reads like an espresso love letter to thermodynamics and hydraulics. In plain terms, the core claim was about using a mechanical pump driven by an electric motor to deliver water at constant pressure through a heat exchanger boiler system, coupled with a group head that maintains thermal stability via a thermosyphon loop, and a pre-infusion valve that gently wets the puck before full pressure hits. Translation: steady, repeatable pressure, consistent temperature at the group, and a little soft start that reduces channeling. Fun nota bene. It's called E61 because of a solar eclipse in 1961. Espresso by starlight. That name stuck, and so did the feel. With the pump, baristas didn't pull shots anymore. At least not literally. They flipped a toggle, and a rotary pump pushed water right at 9 bar. The heat exchanger snaked hot water through a steam boiler, keeping brew water close to target without boiling it. The thermosyphon circulated hot water through the group head, stabilizing temperature where it matters, in the metal that touches the portafilter. Those claims mattered. They created an ecosystem. You could standardize training, scale cafes, and make shots taste the same in Milan and Minneapolis. The E61 group design became an open standard of sorts. Countless machines riffed on it. And that's when espresso went from novelty to global habit. Two design philosophies were now set: gravity drip with paper precision, and pressure espresso with pump precision. The next question was, can we bring cafe-level control onto the kitchen counter? And can we sell you the ingredients one cup at a time? The 1970s answered the first part with a cheerful beep. Mr. Coffee arrived, and the American countertop would never be the same. Inside that brown plastic box was a very smart flow path. In plain claim language, the typical automatic drip patent from this era reads like a brewing appliance comprising a reservoir, a resistive heating element adjacent to a water conduit configured to generate a bubble pumping action, elevating heated water to a spray head for distribution over a bed of ground coffee in a filter basket, and a warming plate regulated by a thermostat to maintain temperature. The magic is the bubble pump. As water heats in a constricted tube, steam bubbles push slugs of hot water upward to the shower head without needing a mechanical pump. The point wasn't artisanal perfection. It was consistency and convenience on a timer. You could set it, sleep, and wake to a half-gallon of drinkable drip. It wasn't the last word on temperature control. Many early models ran cool. but it nailed the daily ritual. And then Joe DiMaggio told America to buy one. That was that. But a different model of control was brewing in Europe: capsule systems. In the mid-1970s, Nestlé's Nespresso concept locked the variables, grind, dose, tamp, inside a sealed capsule. The early capsule patents, in plain terms, claimed a sealed portion capsule with a thin membrane. During extraction, water under pressure is injected into the capsule, which deforms against a perforated plate or spikes. The membrane ruptures in a controlled pattern, and the beverage is filtered and dispensed. The machine's claim centers on that controlled rupture and pressure profile. Here's the key. The capsule is both an ingredient and a pressure device. The foil top, the capsule shape, the internal filter, every square millimeter dictates flow resistance. Consistency is baked right in. The anecdote behind it? An engineer watched baristas pump a bit of air into the water and realized you could pre-saturate and modulate flow inside a capsule. It was cafe thinking in miniature. Fast forward to the 1990s, and Keurig brings the K-Cup to offices, and then to homes. The K-Cup's core claims, in plain speak, were about the cartridge and the machine's piercing and flow system. A disposable cartridge with an internal filter for holding ground coffee, sealed by a lid. A brewer with an inlet needle that pierces the lid to inject hot water, and an outlet needle that pierces the base to drain the brewed beverage, with a controlled flow path to manage steeping and extraction. The cartridge is the consumable. The brewer is the razor. These design claims had massive business consequences. If your capsule design is unique and enforceable, you control the market. When key K-Cup patents expired around 2012, generic pods flooded in. Keurig responded with Keurig 2.0, which tried to authenticate approved pods using markings on the lid that the machine's optical sensor could detect. If the mark was missing, it wouldn't brew. DRM for coffee. Predictably, the internet rebelled. People found sticker hacks and third-party lids to spoof the sensor. The lesson? You can patent a foil circle, but the public will meme it. Nespresso took a different approach. As older patents expired, they rolled out new capsule geometries, like the dome-shaped Virtuo, and machines that read barcodes on the capsule's rim. Those codes told the machine how to spin and brew each pod. It's not just pressure now, it's centrifusion, swirling the capsule to generate pressure via centrifugal force, while the barcode dictates water volume and speed. Different claim set, same idea. Align engineering and law to steer the consumer toward your ecosystem. Let's zoom back. What did the claims actually do in practice? They froze variables: pressure, flow, grind, temperature. These are the four horsemen of espresso and drip. Melitta's paper standardized flow resistance. Gaggia's lever standardized pressure by design. Faema's pump standardized both pressure and heat. Mr. Coffee standardized household convenience. Pod standardized everything in a tiny consumable you have to keep buying. And the oddities at the edges? They tell the future. Portable espresso makers, little hand pumps with a piston and a brew chamber, often claim a manual pressure generation mechanism coupled with a sealed brew path. They're Gaggia in your glove compartment. Cold brew gadgets claim flow-through or agitation patterns that speed up extraction at room temperature, sometimes with vacuum cycles to accelerate diffusion. Refillable pod kits claim adapter interfaces that mate with proprietary piercing needles without leaks. Every hack is really a microclaim: a shape, a seal, a path for water. So what wins? It depends on what you prize: control, speed, cleanup, ritual. Underneath it all, the best designs are honest about water and time. And the best patents are honest about what problem they actually solve. Here's the cheat sheet for your next coffee debate. Gravity versus pressure. Early percolators and siphons taught us how water moves. Paper filters made gravity brewing precise by adding controlled resistance. Espresso proved pressure could emulsify oils and transform flavor. Claims matter because they lock down variables. A good claim isolates a physical pathway, paper porosity in drip, piston and cylinder in lever espresso, pump and thermosyphon in E61, piercing geometry in pods. Each one corners a piece of the brewing puzzle. The business model hides in the parts. Melitta paired a durable cone with disposable paper. Capsule Systems paired an expensive machine with a permanent need for consumables. When patents lapse, markets explode with options, unless you invent a fresh lock. Convenience rides on predicted physics. The bubble pump in drip, the pre-infusion valve in espresso, the foil dome in a capsule. Each is a promise that hot water will behave on cue. Sustainability is a design choice, not an afterthought. Paper filters compost. Capsules can be recycled if you jump through hoops. Refillable pods and paper-lined baskets try to square flavor with footprint. Patents can encourage or discourage that. Ritual still matters. Levers invite a dance with pressure. Pour-overs reward technique. Pods reward pressing a button. There's no wrong joy here, just different authors of the story in your cup. Your coffee maker is a tiny treaty between physics, patents, and your patience. Percolators taught us circulation. Siphons made vacuum into a parlor trick that works. Melitta's paper made drip clean and repeatable. Then, Gaggia's lever turned pressure into crema. Faema's pump turned skill into consistency. Mr. Coffee automated the morning sprint. And capsules, love them or not, bottled up complexity so you could sip simplicity. The through line isn't just technology, it's control. Every great coffee innovation has been a new way to control one stubborn truth: how hot water meets ground beans over time. And every great coffee patent is a verbal diagram of that meeting. What gets sealed, what gets pierced, what gets heated, and how the liquid escapes. The next wave? It's probably less about higher pressure and more about smarter profiles. Machines that read your beans and adapt in real time. Pods that compost themselves without drama. Or refillable systems that finally feel seamless. Maybe we'll see open standards that blend cafe-level telemetry with kitchen-level convenience. Or maybe we'll fall back in love with levers and kettles. It happens every few years. Either way, the stakes are the same every morning. One cup, one set of choices. One tiny battlefield in your kitchen. Fought with better claims, better seals, better heat, and hopefully, better coffee. All right, your turn. Back in the Engage section, I asked, what's your go-to coffee maker right now? And what one little improvement would you patent for it? Drop it in the comments. Be specific. If your team pour over, would you patent a new paper texture to control flow? If you're on an E61 machine, would you claim a pre-infusion tweak? If you're a pod person, what's your dream reusable capsule design? No leaks. Full crema, easy clean. I'll pin our favorite micro patents and sketch a few of them in a future episode. Your kitchen, your claim, go.